If a piece of code is not running the way we want or expect, then we need to find out what's causing it and hopefully fix it. This is a process known as debugging. Most programming languages have the ability to output words or phrases to the monitor, but with Arduino, there's no easy way to connect a monitor to it, which makes debugging quite difficult. However, there are many ways to debug code in a microcontroller, and one of the easiest ways for us is to use something called the serial monitor. In addition to sending the compiled program from our computer to the Arduino, the USB connection on the Arduino also allows us to send characters from our program to our computer to be displayed in a special console. This can prove very useful in tracking down hard-to-find bugs in your code. What we're calling serial communication is actually a very simple communication scheme that uses the universal asynchronous receiver transmitter on the microcontroller. This is commonly referred to as UART for short. This type of communication for our Arduino uses 5 volts for logic 1 and 0 volts for logic 0. Every message sent using UART generally has 8 bits of data, or 1 byte. Messages being sent to the computer from the Arduino are sent from pin 1, which is marked with TX for transmitter. And messages being sent to the Arduino from the computer are received on pin 0, which is marked with RX for receiver. This means that when we initialize serial communication in our code, we can no longer use pins 0 and 1 for anything else. Now, these pins aren't directly connected to our computer. They are actually connected to this other chip on the board, which acts as a serial to USB translator. This lets our computer talk to the microcontroller. I know that was a lot of information to take in, but don't worry. We'll go over digital logic and UART in more detail later in the course. For now, just remember that we can have our Arduino talk to our computer, and this is a very important step for learning how to code on the Arduino, as we'll see in the Programming Basics section. To use this connection, we won't need any additional hardware. Just connect a USB cable between the Arduino and your computer. Open the Arduino program and select File, New, so that you are working with a blank sketch. In the setup function, write serial.begin, open parentheses, 9600, close parentheses, semicolon. Note the capital S and don't forget the semicolon. Serial, in this case, is an object, which we will cover in more detail later. Just know that objects can contain any number of data members, which are just pieces of information, and they can contain member functions, which tell the object to perform actions. We call the member function begin, which is part of the serial object. This tells the serial object to perform whatever initialization steps that need to happen in order for us to send and receive data on pins 1 and 0. We also pass the number 9600 as an argument to the member function. This is the speed with which we want to communicate. In this case, we want 9600 bits per second. Move down to the loop function and write serial.println, open parentheses, open quotes, hi, close quotes, close parentheses, semicolon. This is another member function in serial, and it allows us to transmit letters and numbers. What do you think will happen when this function is called? Here, we want to send the string hi out of the TX pin to our computer. We will use the serial monitor within Arduino to read these messages. Print allows us to send these characters, while println means print line. Println will send the string followed by the carriage return and new line characters, which has a similar effect as pressing the enter or return key on your keyboard when typing in a text editor. Next, write delay, open parentheses, 1000, close parentheses, semicolon, which will make the Arduino wait for 1 second. Press the upload button. You can save your work or just press cancel. Once complete, press the serial monitor button, which looks like a magnifying glass. You should see the word hi appear on a new line once every second. This is great for seeing how the serial monitor works, but how might you use this for debugging code? One way is to print out the contents of variables, which we'll do in a later section. Another way is to insert serial.print or serial.println statements at various points in your code to see if your program is reaching those points. Let's see how to use the serial.print statement in conjunction with serial.println. Underneath serial.begin, write serial.println starting in quotes. Because it is in the setup function, this will only print once to the terminal. Delete your code in loop and write serial.print, open parentheses, open quotes, capital A, space, close quotes, close parentheses, semicolon. This will print a capital A to the terminal followed by a space. Because it's not println, we will not jump to a new line. Write delay, open parentheses, 1000, close parentheses, semicolon. Then write serial.println, open parentheses, open quotes, capital B, close quotes, close parentheses, semicolon, which will print B followed by a new line. Then delay 1000. Press upload, save your work if you wish, and open the serial monitor. You should see starting printed once. The letter A should appear, followed by B 1 second later. Then, on a new line, A will appear again, followed by another B. By placing serial.print and serial.println statements throughout your code, you can see when certain things are executing and in what order. Knowing how to use the serial object in Arduino can be extremely useful for having it print out information when you need it. We'll be using it extensively in the Programming Basics section, mostly to print out the results of math operations. For now, I highly recommend trying the challenge. It will teach you how to use the serial object and make changes to it to print out something you want.